right, let's go ahead and move on to example 3. It says, determine if the following scatter plot depicts a positive correlation or a negative correlation. So it's very simple. It's positive when as x increases, y also increases. And it's negative when as x increases, y decreases. So let's take a look at this graph. X is increasing going in this direction. Y would be increasing going in this direction. But here we see that as x is in the increasing way, that y is actually decreasing, and therefore it is a negative correlation. Please press pause, go ahead and solve this, come back when you're ready and we'll finish it together. Okay, a local medical school is studying growth of students in grades 1 through 12. The height of each student in inches and the length of each student's foot in centimeters is recorded, and a scatter plot is constructed. Do you think the scatter plot shows a positive correlation or negative? And is there causation? Well, when you think about it, if we had a graph here, and we've got their height in feet and their foot or feet in centimeters, the thing is as a person grows taller, their feet tend to get bigger. So my guess would be a scatter plot would be something that would look a little bit like that. And there is a positive correlation because as x increases, y also increases. So we know that it's positive, and is there causation? Is there a reason that their foot is getting bigger? Yes, as they're getting taller, taller people tend to have larger feet. So taller people, not always, but generally, tend to have larger feet. So because of that, yes, there is causation. And with that causation, we can say that the explanatory variable is that they're growing taller, and the result or the response is their foot is getting larger. All right, example 4. It says an elementary school principal compiled the following data about 10 students at Comset Elementary School. The first number represents a student's height in inches. The second number is the student's reading level. Create a scatter plot of the data. Do you think a person's height causes a higher reading level? So I want you to go ahead and go back to your calculator. In your calculator, you're going to go ahead and you're going to list your items. So we've got, going back into our list, so stat and edit, and you can see that I've already gone ahead and updated these values. I want you to press pause, go ahead and input the same values. When you're ready, come back and we'll walk through the rest of this together. Okay, now that you've entered all of them in, we're going to click up here on window, because again we're going to change the window that we're looking at. The lowest number that we're looking at is 48, so you can see I put the X minimum to 40. The highest that we're looking at is 63, so you can see I put the max to 70. On the Y side, which is that reading level, the lowest is 4.1, so I put 3. Highest is 10, so I put 12. Now that you've put that in, go ahead and graph it, and this is what you're going to see. All right, so as we're looking at this, it says create a scatter plot. We did that. And it says, do you think that a person's height causes a higher reading level? And the answer here is no, it doesn't. Their height has nothing to do with their reading level. Now, that being said, can we explain then why, when looking at this, there is an obvious positive correlation? Because as you see here, as the values of x are getting bigger, in a general way, the values of y are getting bigger. So, we've got to keep in mind that sometimes they can be related, but not causing one another. So, logically, if I look at this, I would say that as a person grows taller, what else are they doing? Well, in most cases, as they are growing taller, they're also growing older. And as they grow older, hopefully, their reading level improves. So indirectly, we can say here that one doesn't have anything to do with the other, but there are other variables that we could look at that determine why there's a positive correlation. And here, it's simply as they grow older, they grow taller. And as they're growing older, they have a better reading level. And so we see that there is no causation here, but there is a correlation. All right, thinking of an example of data that might have a negative correlation, but there is no causation. And I will tell you, this is a little bit tough to do, so I want you to press pause, think a few moments, and then I'll come back and give you at least one example that I came up with. All right, so think of an example or data that had a negative correlation. So as x is getting bigger, y is getting smaller, and we need it to have a negative correlation. So I would say miles on a car and the balance on the car loan. Now when you think about this logically, the longer you have the car, the more miles are going to be on it. And the longer you have the car, the lower your balance, your loan balance is. But when looking at it, does the mileage in the car have anything to do with the balance of the loan? Absolutely not. And I'd love to hear if you want to email me any other examples of a negative correlation where no causation existed. All right, last example for this unit. It says the scatter plot shows the relationship between the number of text messages made by each of 10 juniors while studying for Mr. Galati's chemistry test last week and the scores on their tests. Describe the trends when you see the data. So when you're looking at the data here, you can see that it is literally scattered all over the place. And so in this situation, we could say that there is no either positive or negative correlation. There's no correlation at all. How many texts they sent has nothing to do with their score on the test. And sometimes that's what you'll find, and that's what you need to know that it looks like. It's a scatter plot that literally is all over and has no clear direction. All right, finally, students in a biology class measure the circumference and diameter of every tree on the school property. They create a table of ordered pairs and plan to draw a scatter plot. Should there be a positive correlation or a no correlation? Well, the first thing we have to see is the circumference of a circle is actually directly related to the diameter because the formula is the circumference equals pi times the diameter. So as the diameter increases, the circumference is also going to increase because it's part of the formula. And therefore also the smaller the diameter, the smaller the circumference. And that's it for us on this one. Good job, everyone.